In this video we're going to look at solving three equations with three unknowns. You could do this using a matrix, but I'm not going to do it using a matrix in this video. I'm just going to do it by basically elimination. So kind of the same method that you'd use with two equations and two unknowns. So the first thing you want to do is try to figure out which variable you want to eliminate, and you can do that by looking at the coefficients on each variable. And what you're looking for is if a variable has two coefficients that are the same, that's going to make that variable a little bit easier to get rid of. So let's take a look. On our x we've got basically 1, 3, and 6. On our y's we've got -1, 2, and -3. And our z's we've got 1, -3, and 2. So no variable has coefficients with the same coefficient. Or even opposite coefficients would be nice. Like say if we had a -3 and a +3, that would be nice. So really no variable is going to be easier to get rid of than any other variable in this problem. So let's go ahead and get rid of z. Okay, so what we're going to do is we're going to label these equations. Let's label this one E1 for equation 1, and then E2, and then E3. So what we want to do is add together two of the equations to make the z's drop out. So let's say we're going to add equation 1 and equation 2 together and try to get the z's to drop out. Well, in order to do that, we're going to need a 3 right here in front of this z. So the first thing we're going to do is we're going to take equation 1 and we're going to times it by 3. So let me write that like 3 times equation 1, and we're going to put that right here. Okay, so 3 times equation 1 would be, let's do this in blue, 3 times, so I got to take 3 times everything here. So 3 times 6x is 18x minus 3y plus 3z equals 3 times 29, let's see, 3 times 30 is 90, take away 3 is 87, so -87. Okay, so now I'm just going to move equation 2 over here underneath 3x plus 2y minus 3z equals -1, and I'm going to add these together. See, my z's are going to drop out, that's what I wanted. So we get 21x minus y equals -88. Okay, we're going to leave this here for a minute. We've got an equation with just x and y, and we want to create another one of those. So we're going to go back over here, and we've already done equation 1 and equation 2 together, so we could either do equation 1 and equation 3 or equation 2 and equation 3, and we're still trying to get the z's to drop out. Now if I do equation 1 and equation 3, I'd have to times equation 1 by -2 to get the z's to drop out. If I do equation 2 and equation 3, to get the z's to drop out, I'm probably going to have to multiply both equations. So I'm thinking that might be a little more work. So I think what I'll do is multiply equation 1 by -2. -2 times equation 1. So that I can add that to equation 3 and the z's will drop out. Because if I times this by -2, I'll have -2z. Okay, so let's do that in blue again. So -2 times everything in equation 1. That's going to give me -12x plus 2y, because a negative times a negative is a positive, minus 2z equals 2 times 29, let's see, 2 times 30 is 60, take away 2 is 58. So we got positive 58, because a negative times a negative is a positive. Alright, now I'm going to bring E3 down like I did before. I'll put E3 here. And for that other one we did the same thing. So E3 is x minus 3z or 3y plus 2z equals -18. Now we'll add those together. So that's 1x, so I end up with -11x minus 1y, or just minus y. The z's drop out, equals, looks like 40. Alright, so now let's call this equation 4, I guess, right here, this one we made. And then this other one we made, we'll call that equation 5. So now we're going to take equation 4 and equation 5 and try to get those to drop, get one of the variables to drop out. Basically, we're down to 2 equations with 2 unknowns. Let's write those over here so we can kind of look at them. One thing about doing these problems that gets people in trouble is just teeny little mistakes. There's so many places to make a little mistake that, keeping organized and maybe writing this E1, E2 business might help you to not make those little mistakes and just try to keep your problem organized and multiplying by negatives, watch your negatives and all that stuff. Alright, so this one's set up pretty nicely for elimination with my y's. I just have to make one of these a positive y, so I think I'll just multiply through one of these by a -1. And that's pretty easy to do without rewriting everything. Let's do that in red, I guess. So if I multiply, it doesn't matter which one, I'll just do the bottom equation by a -1. That would change that to a positive, that to a positive, and that to a negative. So now we can add the 2 equations together and our y's will drop out, so that gives us 32x. Y's drop out equals -128. So now we're down to 1 variable and 1 equation. We just have x, so we can just divide both sides by 32 and find out what x is. Let's see, how many times 32 going to 128? I think 4. So that'll be a -4. So now we've got one of our 3 answers, and now we're just going to work backwards and plug this in. So we're going to plug -4 either into equation 4 or equation 5. Oh, you know what? Where I put a 3 right there, this should be equation 2. It doesn't really matter, but we used equation 2 that first time. I just noticed that. Okay, back to what we're doing. Let's plug this into equation 5. We want to plug it into one of them that just has x's and y's, and it really doesn't matter which one. So let's take equation 5 again. Equation 5, since it's right here and I got room. And let's plug in -4 where the x is. So I get -11 times -4 minus y equals 40. So that gives me positive 44 minus y equals 40. And you're going to see we're going to solve for y here. Then we're going to know what y is, and we're going to be almost done. So watch your negatives here. Negative y equals -4, so y equals 4. Cool. Alright, we got our x and our y. Now all we need is our z. So we're going to find an equation that has x, y's, and z's, which is these first 3 up at the beginning. You're going to pick one of these 3. It shouldn't matter. You're going to plug in the x and the y and solve for z. And you should get the same value for z no matter which one of these 3 equations that you pick. So let's go with one that looks the easiest. Now let's go with E3. And maybe we can do it right here in this space, since I have some space right here. This is the thing about these problems. You kind of got to manage your space. Keep organized. This probably isn't the best place to do it, but that's okay. Alright, so I'm going to plug in my x, which is -4, minus 3 times, I'm going to plug in my y, which is positive 4, plus 2z equals -18. So I'm going to solve. So I got -4 minus 12 plus 2z equals -18. That gives me -16 plus 2z equals -18. Add 16 to both sides. I'm going to write it up here because I'm running out of space. Plus 16 on both sides. So that gives me 2z equals -2. So z equals -1. And there is my third value. So my answer, the best way to write it is as an ordered triple. X, Y, Z, -4 for X, 4 for Y, -1 for Z, and that's your answer. Now you could go check this, take this X, Y, and Z values and plug it in. X, Y, and Z. In this first equation, if you plug these in, it should equal -29. If you plug in X, Y, and Z in the second equation, it should equal -1. If you do it in the third equation, it should be -18. That's the nature of the solution, is that this X, this Y, and this Z make all 3 of these equations true. Hope that helps.